So we are starting functions today. Recall that in class 11 you have learned about the basics of functions, how a function is defined. So you have learned that function is a special type of relation. Special type means there was two sets, suppose A and B. This was two sets, and there was elements here and here also. So a relation being function, there should be every element in the set A related to a element, an element of B. All the elements of set A, and later we called the set A as the domain and B the codomain. Okay, so all the elements of set A must be related to is an element of set B. It may be unique or may not be unique, but there were two conditions. Condition 1 was each and every element of set A. That means the function is defined from set A to set B. From where the function is defined, that is set A, every element of set A should related to an element of set B. And condition number 2 was that this each element should related to exactly one element. That means from this set A, one element should not mapped or related to different elements. One element should map to one element only. So in these two conditions, I have never told that two different elements from set A cannot map to same element. I mean, suppose this element, okay, so this element cannot map to different elements. This cannot happen, and this can happen that this element mapped to this element, and also this element mapped to this element, or more than two. Any other element can also map to this element. So when f is a function, we call this the element of set A mapped to the set of elements of B. So A is called domain and B is called codomain, and the set F of A, this is called the range. So also we have learned to think function as a machine that take inputs and give outputs. So A is the set of inputs and B is the set of outputs, and plus any other extra elements. Extra elements. But the set of outputs, this set is called range. Hope this is clear to you. Okay, so for this we are denoting like this. So for function we denote like this: f such that f is from a to b, and then define the function fx equal to some 2x plus 5. This is a function. So clearly x is from a and fx belongs to b. Okay, so now this was part of class 11. Now the part that is in class 12, that is classification of functions. Classification or types of function. So there are mainly two types of function. Mainly two type. One is one function, and that those functions which are not one, those are called many one function. And second is onto function. Those are not onto function, called into functions. Okay, so these are also called as injection. One function is called injection, injective function, injective function, and onto function is called surjection or surjective function. Now examples. Okay, one function. One or injective function. There is a definition of injective functions. Okay, so the definition is in words. If we write it. A function is called injective or one function. So from the name one, you guess, you have guessed that how this function look like. One function, if a function is called one function if every element of domain mapped to a unique element of, okay, codomain, or we can say that every element of domain has a unique image in codomain. That means pictorially it looks like this. Suppose this is a, and this is set A, the domain, this is set B, this is the domain set, and this is codomain set. Okay, so here there are elements like this, and here also there are elements like this. Okay, so for a one function, every element of set A, every element of set A should be mapped to a unique element of set B. That means this element should map to only one element of set B, and this set should be mapped to one element of B. This element should be mapped to another element. This element should be mapped to another element. This image is another element. For this, the image is another element. Okay, for every element. So a relation being function, all the elements of set A should have should have exactly one image for being a function. And now we are talking that every element of the domain have only one element and exactly one element, I mean image. So here this element has different image, this element has different image, this element has also different image, all the elements has different image. See in this picture, this element and this element has same image, this element, and we have already told that any element of set A cannot have two images. On the set, the elements of set A has to have only one element, the image. Here these two element has same image, this, but for one map, every element of set A have different element, different image in B. See, no element here has mapped to, no two element here is mapped to one element in set B. Okay, clear?
Yes. Okay.
So I will come to later that how to check one and on two maps. Before that, I am giving some examples and the definition. So how to check a function is one or on two or many one or on two. So I will give that uh, algorithm later. If a function is not one, then it is on two. So for on two functions, for okay, sorry, no, not on two functions. This is many one function. Many one functions. Many one functions. Two or two or more than two elements have same image. That means what? It is like this. Suppose this is a set. This is a set. Okay, so these are the elements. Here also we have to draw. Okay, this element maps to this element. These elements also map to this element. This element maps to this element. This element maps to this element. This element also goes to this element. This element goes to this element. And this element also goes to this element. See that for this element here, it has three pre-images. For this is set B and this is set A, this is domain and this is B is codomain. And for the set, for the elements of B, we told that we tell usually say that the elements of B has a pre-image in set A. Okay, so it has three pre-images. It has two pre-images and it has also two pre-images. Notice that in the both of cases, there are some elements in B which are free. That means there are some extra elements in set B that has no pre-images. So there are some element which has no pre-image. That means the range. This is the range set. The range of f, the function f. Suppose this is the function f here from A to B, is a subset of B. That is the codomain. This and for also this, the range of G. Suppose I am is a subset of B set. This is function G. Okay, so this is one and this is many one. Now on to function. Okay, before that into function. First do into functions. Okay, this G function, this G function, this G function is a into function. Why? Because in this function G for G for G, the range of G is a subset of B, that is the codomain. This is called into function. So the definition is very straightforward. The definition that there are some elements in the codomain. So this is a not definition. Codomain that does not have pre-images. So you can easily see that this element, this element, this element, this element, there are so much elements, so many elements. These elements, these elements, these all these elements have no pre-images. So this is why the range of G is a subset of B. Okay, so we can write the it a proper subset. Okay, we can write it as a proper subset. Proper subset. Okay, so here it is proper subset, but when we take uh, some countable or uncountable, countably infinite sets, there is a, I mean, useless to say about proper subset or improper subset like that. So here it is finite, then we can say that it is a proper subset. So these elements has no pre-images. So this is a into function. And what is onto function? Onto function is onto function. For onto function, the range of G is equal to, exactly equal to the codomain. That means what? Each and every element of uh, B. Here I am not writing some definition. That is why I am using this B and G, because I have taken some examples like this. This is B set, this is A set, and this is G function. So every element of set of B has at least one pre-image. Why I have written at least one pre-image? Because I never said that a function that is onto may cannot be a many one function or one function. So if a function is many one function, then some elements of the set B has more than one pre-images. So in onto function like this, okay, I am taking two examples. Oh, so these two are onto functions. Suppose I am taking these as onto functions a b 1 2 3 4 5 6 7. 1 2 3 4 5 6 7 8. Okay, so here we have to draw another. So now this is here, 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 and this is here. Now again I am drawing another picture. See, this is also another set. Suppose we take it C and D. So here you can check that. Okay, which color should I take? This. So see that each and every element of set A each has a image in set B, that is it is a function. So I am taking this as f function, and no element of set A has two image. That means this is a function. Next, for the set B, no element is free. That means every element of set B has a pre-image. Every element is connected to a element of set A. Notice that every element of B has, I have written here that at least one pre-image, but the specification, the speciality of this function f is that every element of B has exactly one pre-image. But for this case, suppose this is function h, it is onto function, and it is also onto function because no element of B is free. Here also no element of B is free. but it is I mean, but here for the function h, the elements of D set, that means codomain set, has more than one preimages. Like this element has one preimage, this element has two preimage, this element has one preimage, this element has two preimage, and this element has one preimage. So in D set, this element and this element has more than one, or these two has two elements, two preimages each. So now for the finite sets, for some finite set, or maybe it can be extended to the infinite sets also. So you can see that if a function is onto, so see h function is, the function h is onto means no element of set D, I mean codomain, is free. I mean, so that means the function h cover up every element of the set D. So there is no element of D is uh, left out. And see that for onto function, sorry, one function, for one function, I mean for function no element of the domain is free, and for one function maybe the codomain has more elements. So from this notion we use, I mean this is extra, I mean note, extra note. If between two sets A and B, A and a one function exist, that means cardinality of A uh, is less than equal to cardinality of B. This is one. And if between two sets A and B, A onto function exists, that means cardinality of A is greater than equal to cardinality of B. Okay, so here you can see that this onto function, here cardinality of A is 7, 1, 2, 3, 4, 5, 6, 7, and for the set D it is 1, 2, 3, 4, 5. So here it is 7 and the cardinality of D is 5. So that is why I have written that cardinality of A is greater than cardinality of B, and for onto function cardinality of A is less than cardinality of B. Okay, whatever. So this f function is a special type of function. See, this function is onto function, and this is also one function. Why 1 1 function? Because every element of set A has exactly, sorry, every element of set B has exactly one pre-image, and every element of set A has only one image, that is the definition of function. So for 1 1 function, every element of set B has to be has to have only one pre-image. So here every element of B has only one pre-image, and also every element of B has a pre-image. So that means this function f is onto function plus 1 1 function. So this type of function, which is 1 1 and onto, this is called bijective function. Bijective function or bijection. Okay, so this is the last note. If between two sets A and B, at least one bijective bijective function exists, then cardinality of A equal to cardinality of B. Okay, so what is a bijective function? A bijective function is that function which is both 1 1 and onto function. Okay, now I will tell how to check whether a function by bijective or injective or surjective, how to check. Okay, so now we will talk about how to check a function whether it is 1 1 or onto. So you have seen that for 1 1 function, for 1 1 function, no two elements, suppose this is x1 and this is x2, and x1 comma x2 belongs to the domain. Okay, for simplicity we are taking this set as domain, and this set is codomain. This is function f. So x1 and x2 are two elements of the domain. We are not telling that these two are different element or same element. We are just taking two elements and we are applying f on them, the function. This is fx1 and this is fx2. Now we will equate fx1 equal to fx2. Suppose this is fx1 and this is fx2. So we are assuming first that this fx1 and fx2 are both same, That means this is fx1 as well as this is fx2. These two are not different. These are same. So we assume or let fx1 equal to fx2. So at first we are taking two elements from the domain. X1 and x2 belongs to domain. Okay, I am writing domain. We have taken domain as a. So x1 and x2 belongs to a, and after that we let or assumed that fx1 equal to fx2. That means these two elements x1 and x2 has same image. That means fx1 equal to fx2. This x1 equal to x2 has same image. So from this we will prove we will prove that x1 equal to x2. That means whenever the images are same, fx1 equal to fx2, the f image is same, then those element from domain should be same. That means each and every element of the domain has unique image. Okay, and this is one way, and another way is let x1 comma x2 belongs to a and x1 not equal to x2, and also let that x1 is not equal to x2. That means these x1 x2 are two different element of the domain. That should imply that fx1 equal to fx2. This is not equal to. So x1 x2 are different element, then their images should be different, and if x1 equal to x2, that should imply fx1 equal to fx2. Or actually in reality we assume first that we don't assume anything about x1 and x2, then we'll let fx1 to be equal to fx2, and then we prove that the opposite part, that x1 equal to x2. This is one case, and this is second way. So this was first way and this was second way. This was the first way, this was the. So these are two ways to prove a function 1 1. Okay, now take an example. Suppose fx is equal to 2x plus 5. Now we are taking two arbitrary element from the set of domain. So let x belongs to R, the set of real number. Okay, so take two element x1 and x2. For this example, we will first let assume that fx1 equal to fx2. So if fx1 equal to fx2, what does it mean? It means that 2x1 plus 5 equal to 2x2 plus 5. This means that 2x1 equal to 2x2. 5 cancelled, and again 2 cancelled. So x1 equal to x2. So we have assumed that fx1 equal to fx2. That means x1 and x2 has same image. and eventually we have proved that this implies that x1 equal to x2. That means whenever two elements are same, their images are also same. That means this implies f is 1 function. Okay. Now take another example, fx equal to x square plus 1. Again, we are taking two different elements. Suppose x1 comma x2 belongs to R. So x belongs to R. Now fx1 equal to fx2. This implies that fx1 means fx1 fx1 is what? x1 whole square plus 1, and fx2 is what? x2 whole square plus 1. So I don't have to tell this. I think this will is easy to. I mean, this is clear to you. What is fx1 and what is fx2? So that means x1 whole square plus 1 equal to x2 whole square plus 1. This implies that x1 whole square equal to x2 whole square. So now this don't give only one solution, that x1 equal to x2. This gives that x1 equal to plus minus x2 or x2 equal to plus minus x1. So that means for x1 equal to x2, fx1 equal to fx2, and also x1 equal to minus x2, fx1 equal to fx2. That means what? For two different value of x1, that is what? One is x1 and another is minus x1. One is x1 only and another is minus x1. fx1 is equal to fx minus fx1. So basically we have taken x2 as minus x1, or we can take x1 as minus x2, whatever. So for different values of x1, i.e. x1 and minus x1, fx1 and minus fx1 is both same, that is equal to x1 whole square plus 1. So that means f is not a 1 function, that is f is many one function. Many one function. Clear? So uh, I think you have understood this, how to check one function, right?
Yes.
Okay, so now on to function check. So for on to function, according to the definition, what was on to function? On to function was for every element of set B, there should be at least one pre-image. That means every element in B should have mapped to an element of A. That means here for checking onto function, we will take let y belongs to B. That means the codomain. Okay. So this is y belongs to B. the codomain. Now for this we will check there exists for y. So because y is arbitrary, we have taken we have not chosen any specific y, some specific y from b. We have chosen an arbitrary y from b. So for y there exists for y, suppose this function is f function, there exists a an element x belongs to the set A such that fx equal to y. So now when we learn inverse function, so I have seen the I have checked the syllabus of 2025 and 26, 2025 and 2026 for this examination. There is no mention about the inverse function, only one function and one two function. But we will learn these things because these are very important for JEE perspective. Okay, so when we learn the inverse function, then we can easily write it as y equal to f inverse x. So when we learn the inverse function, but now for this thing, now we are taking an example because here we let that for any b, any y from the codomain b, there exists an element x from the set A such that fx equal to y. So how to ensure this thing? Suppose let us take this example, the above example, 2x plus 5 and x belongs to y, r. So I haven't mentioned that f is from r to r. So after we specify a function is defined from whether to which function to which function, then only we can talk about one and ontoness. Before that, if we don't specify the codomain and domain, we cannot say a function is onto or one, because if we change the codomain and domain, a function for some domain and codomain, a function is one, but if we change the codomain or domain, a function may not be one, and same for onto. So it is, this function is from r to r, from real number to real number. So fx is equal to 2x plus 5. So take y equal to y belongs to r. This is from codomain. Okay. This y is from codomain. So for this y, so let y equal to fx. That means we are talking about a y from codomain, and we are assuming that for this y, this is arbitrary. For this y, there exists a x such that fx equal to y. The f image of x is y. So that implies that y equal to fx. What was fx? Fx was 2x plus 5. So 2x plus 5. Now from this we can say that y minus 5 is equal to 2x, and also we can say that x equal to y minus 5 by 2. Okay, so x equal to y minus 5 by 2. Now this codomain was real number, the set of real numbers, and the domain was also the set of real numbers. Now tell me, if we take R to be any real number from the codomain, set of codomain, because y belongs to R, the set of codomain, the codomain set, that is the real number set. Now if we put R, y belongs to R, such that y belongs to R. Now for every y, we will get an x, right, from this relation. Y minus 5 by 2. This is a well defined function from R to R. This is also a function. X is equal to y minus 5 by 2. This is also a well defined function. And this function is from real number to real number. There is no problem. So this is why in class 11 there was so much exercise to find the codomain, domain, and range of the functions. So x equal to y minus 5 by 2. So if we put any real number in place of y, we will get a real number, that is x. That means y minus 5 by 2 is a real number. So x belongs to real number. So for every y in codomain R, there is a x in domain R such that fx equal to y. That implies f is onto function. Now for the function x, fx equal to x square plus 1. Now the domain of this function was the real number, set of real number, and I am defining this from R to R again. Now if you try to find out the range of this function, you will get that the range of this function is from 1 to infinity, because x square is greater than equal to 0, so x square plus 1 is greater than equal to 1. So that means the range is from 1 to infinity and 1 is included. So this range is a subset of the codomain R. That means this implies f is not a onto function, but as the range is close 1 to infinity, if we restrict the codomain R in this range, that means if we redefine f from R to minus 1 to infinity, and the definition is same, x square plus 1. Now this f is a onto function. See how we changed a into function to a onto function by redefining this codomain. We redefined the codomain with the range. we restrict the codomain R in between 1 to infinity. Okay, and here also we can make this. So now this function is onto function. Now again we can redefine the function, redefine to make it 1 function. Now f is from, we are taking f is from close 0 to infinity, from close 0 to infinity to close 1 to infinity. Now see, this function is 1 and onto. Now f is 1 and onto function. That means bijective function. Because why it is 0 to infinity? Because for this expression x square, the minus x whole square was also x square and plus x whole square was also x square. So we have taken only the plus x elements from the set of real numbers, and we can also take this. We can also take minus infinity to 0 to 1 to infinity. This also same. So for this, the definition will be fx equal to x square plus 1, and here also fx equal to x square plus 1. No matter, does not, there is no difference. Here x is positive and here x is negative. This is the only difference. But both are bijective. But this f is also bijective. Now, as we told, this is a bijective function. We can say the inverse function. So if f is a bijective function, if f is a 1 and onto function, i.e. a bijective function, then f has inverse function. Such that with the property, inverse function is unique and it has the property f in inverse function, let us say it g, inverse function g, such that, okay, such that, okay, such that g of x is equal to, g of y equal to x, where x is from a and y is from b. So this is the scenario. Suppose this is set a and this is set b. This is the function f and this is x, this is y, and this is the function g. So this is like this, fx equal to y, and the inverse function is gy equal to x. Now when we learn about the composition of functions, then we will see that f compose g is equal to x and g compose f equal to y. So when we learn the composition, then we will see this. Now you can check that when a function is not 1 1 or onto, why the function cannot be bijective. The inverse function, why in the inverse function, why the inverse function cannot exist. So see, there are 4 5. Okay, here also 5. First we take here the 6 elements, the 4 5 and 6. Now suppose this element goes here, this element goes also here, this element here, this element here, and this element here. So this function is not 1 1 function. So when you when you trying to find a function from this a set to b set, this a set to b set, the function is f, and f is not 1 1 function. So what is the problem? When we trying to define a function from b to a set, then there will be a problem for this element, because for this element it has two images, namely this point and this point. So first of all, it will not be a function. At first it will be rejected. So for this function f, which is not 1 1, we cannot define the inverse map. Okay, so this is the problem when a function is not 1 1. Now we are defining a 1 1 map but not onto map. So this is 1 1 map. So this is 1 1 map but not onto map. So this is 1 1 map, no, but not onto map. So here this element is free. That means this is not onto map. Again, when we try to define a map from B to A, then an element of B is free. That means the condition for a function is violated, that every element of the domain should map to or has to have an image. So for the function g, this is the function g, suppose. For g, you can easily understand that for g the domain is b set and the codomain is the set a. So for g, the g function is defined from b to a. That means b is the domain and this is the codomain. So any element of the domain uh, can be free for being g a function. So if g is a function, then every element of the domain set b should have an image in the set of codomain, that is a set, right? So that means it has to be 1 1 and onto map. So if f is a 1 1 and onto map, then we can define its inverse function, that is g from b to a, and g is also 1 1 and onto. It is evident from this. If f is 1 1 and the inverse function g, this is also 1 1. And in the next class we will learn about the composition of functions. Then we will see that if we compose this any function with its inverse function, then we get the identity function. Now this is one function and two function, and we have learned about some familiar functions which are in class 11. That is identity function, signum function, polynomial function, trigonometric functions, like this. We have learned some about some functions. So, and we have also learned to find out the domain and codomain. Now we will check every function whether it is one and two and on two, and whether it is bijective or not. Okay.
Okay.
So that's it for today. We will continue in the next class.